3I/Atlas is transforming right now, becoming one of the most fascinating interstellar objects ever observed. Fresh images from NASA and ESA reveal dramatic activity as it approaches its closest pass to Earth on December 19th. In this video, we explore what these new observations actually show, how scientists detected this sudden burst of activity, and why this rare visitor could reshape our understanding of objects born beyond our solar system. The latest images of 3I/Atlas mark a major moment in our study of interstellar objects. NASA's Hubble Space Telescope captured an updated view of the comet on November 30th, revealing a bright nucleus surrounded by a clear, expanding coma. In this images, stars appear as streaks due to Hubble tracking the comet's rapid movement rather than the background field. This streaking effect confirms how quickly 3I/Atlas is traveling through the inner solar system. Hubble's image showcases a structured, glowing coma shaped by gas and dust escaping the surface after its recent approach to the Sun. Unlike earlier images from July that showed only a faint blur, the new view demonstrates how dramatically 3I/Atlas has changed within months. Scientists believe this increase in brightness and definition is driven by strong sublimation of volatile materials, triggered by the warming effects of solar radiation. But ESA's JUICE spacecraft added an even more captivating perspective. While en route to Jupiter, JUICE photographed the comet from a distance of just 41 million miles, far closer than Hubble's viewpoint. Its navcam revealed both a plasma tail and a faint dust tail, each extending in different directions. The plasma tail appears to stretch upward as charged particles respond to the solar wind, while the dust tail trails behind the comet's path. Together, the images from Hubble and JUICE provide complementary evidence. 3I/Atlas is highly active, shedding material, brightening rapidly, and evolving in real time. The sudden activation of 3I/Atlas has a clear cause rooted in physics and chemistry. As the comet approached the Sun in October, solar energy heated its surface and triggered sublimation, where ices transitioned directly from solid to gas. But unlike typical comets formed inside our solar system, 3I/Atlas appears to contain a different mixture of materials. Early size estimates placed it between 440 meters and 5.6 kilometers wide, making it potentially the largest interstellar object ever studied. Its composition, however, is even more intriguing. Another important factor is its exposure to interstellar space. For possibly millions of years, 3I/Atlas drifted between star systems, exposed to cosmic rays that can alter its outer layers. This long-term irradiation can create dense crusts, modify organic compounds, and leave behind a chemically processed surface that behaves differently when warmed. When the comet passed near the Sun, these layers began to crack and release trapped gases, producing the jets visible in recent images. The plasma and dust tails identified by JUICE also help explain its activity. Plasma tails form when ionized gases interact with the solar wind, while dust tails consist of tiny particles pushed away by sunlight. The fact that both tails are clearly defined suggests a high rate of gas release, along with significant dust shedding from the comet's surface. This activity is a direct response to solar heating, but influenced by 3I/Atlas's unusual composition, which reacts in ways not typically seen in familiar comets. The study of 3I/Atlas carries enormous scientific value because it gives researchers a direct, real-time look at material that originated in another planetary system. While we have detected particles, dust, and gases from distant stars through telescopes, observing a complete object passing through our region provides unmatched insight. The fact that this comet is now extremely active makes the opportunity even more meaningful. One reason this matters is that the composition of 3I/Atlas may differ significantly from that of native solar system comets. By comparing their chemical signatures, scientists can learn how other star systems form solid bodies, how their temperature conditions vary, and whether their outer regions contain similar mixtures of ices and minerals. Understanding these differences helps researchers refine models of how planets and comets form across the galaxy. Another key point is the range of spacecraft observing this object. Hubble, JUICE, and multiple ground-based telescopes are all collecting data. Each instrument measures something slightly different. Hubble provides detailed imagery of the coma, and JUICE captures the tail structure. When combined, these observations produce a complete profile of how the comet behaves and evolves as it moves through the inner solar system. The timing of this activity is also important. Because 3I/Atlas reaches its closest approach to Earth on December 19th, scientists must gather as much data as possible during this brief window. Finally, studying 3I/Atlas helps refine our understanding of interstellar travel mechanisms. The way its surface responds to heating, the way its tails form, and the rate at which it sheds material all paint a detailed picture of how small bodies behave when moving between star systems. 3I/Atlas offers a rare chance to study an interstellar object undergoing rapid transformation as it moves through our region. Recent images from NASA and ESA reveal a bright, active comet shedding gas and dust in complex patterns shaped by both its composition and its journey through space. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Thank you for watching, and see you next time.